Greetings and welcome to day 4 of the 2025 National Invasive Species Awareness Week. Our theme for this year's NISAW is Enhancing North American Biosecurity to Protect Against Invasive Species. My name is Christy Trifone-Millhouse, the Executive Director here at the North American Invasive Species Management Association, also known as NISMA. Now, before we get started today, we talked a little bit about some housekeeping notes. We're really excited to welcome you all. Share with us in the chat where you're joining from. Also, a reminder after presentations today, please feel free to use the reaction button to let our presenters know that you enjoyed their topic. And we will be hosting a brief Q&A, so questions need to be added to the Q&A box, not the chat. And we'll provide some friendly reminders to folks should you find the chat and not the Q&A. All right, so NISAW is an international event powered by NISMA to raise awareness about invasive species, the threat that they pose, and what can be done to prevent their spread. NISAW provides a platform for individuals from local, state, federal, tribal agencies, regional organizations, private industry, and citizens to discuss legislation, policies, resources, and improvements that can be made with elected officials and decision makers. And this week is not only a time for learning, but a time for action. And we will have a call to action at the end of our presentation today that we urge you to participate in. And so throughout the week, we'll be sharing links, as I just mentioned, with you in an effort to connect you with your US senators and House representative. And we want them to hear our collective voice and to learn about the importance of this work and why we need support and funding to continue to press forward. For those who want to take a more active role this week, please head to nisma.org and find the NISAW toolkit filled with template social posts, press releases, PSAs, and so much more. If you're currently connected to us on socials, you've seen all of the activity. Please repost, please share with folks, please like, be active during NISAW. And if you aren't currently connected, find us and become active today. All right, so we've got quite a week planned. We're at our 4th day. And all of our presentations this week have focused on our theme of enhancing biosecurity at all levels. So presentations yesterday featured Dr. Elliot Parsons and graduate student Olivia Jarvis, who shared with us new efforts related to Pacific Island biosecurity. If you weren't able to attend live, we'll be posting these presentations on our YouTube channel after the event. And I encourage you to visit our website to register for these webinars. We've got some coming up tomorrow that you won't want to miss. I would be remiss if I didn't mention that our agenda has changed quite a bit over the last month and is continuing to change this week. We appreciate your patience and understanding. I'd like to take a moment to thank those federal employees who have invested their energy and heart into this work. Some of them are no longer leading those efforts at the national scale, while others are still holding strong. And NISAW is driven by education and action. And as partners, we recognize that now is not the time for us to take a step back and sit down, but rather to stand up and move forward. And I encourage you to activate your networks behind our calls to action and to provide support to programs that need a bit of glue right now in any way that you can. Through partnership and collaboration, we are stronger. And really, this is the essence of NISMA. So as leaders of NISMA is deeply vested in our mission to empower invasive species management across North America. We are led by an 18-member board of leading experts and professionals with supporting committees that I encourage all of you to consider joining. A strong NISMA team helps to support all of our programming, and our membership supports all that we do and continues to grow in numbers by the day. NISAW is one of our most far-reaching events with over 2.9 million people participating in last year's event. And I mentioned find us on socials. We are hoping to beat that number this year, to reach even more people. So be a part of that and continue to like and share. So here at NISAW, we provide the connections, the tools, and the voice that you need to address invasive species. And we frame our programs around these core pillars. We work hard to provide opportunities for collaboration and connection through our webinars, summits, and annual conference. We equip our members and those in the invasive species community with tools needed to manage and educate the public about invasives. And finally, we strive to provide a collective voice on a national platform to advocate for relevance and support through our government relations programming and events like NISAW. Some of our upcoming events you won't want to miss. The 2025 National Forum on Biological Control in Annapolis, Maryland, will be hosted April 14th through the 17th. The meeting themes revolve around biocontrol research, management, and impacts in natural areas. We've got some great speakers lined up, so I encourage you to register today if you're interested in networking in person with members of the biocontrol community. Another event you won't want to miss is the 2025 NISAW Annual Conference. Mark your calendars and plan to join us in Lake Tahoe from November 3rd through the 6th. Our theme this year is charting a new course, and we've got some great speakers lined up already and hope to see you there. Registration is open, so head to nisma.org to get registered today. So one of the ways that NISAW creatively funds our mission-driven work is through our NISAW online shop. And this week, we're hosting a special on our handheld boot brushes to celebrate NISAW. Make sure to head to the NISAW shop and take advantage of this offer today and tomorrow. So we'll be sending out reminders, but this deal will end tomorrow. A friendly reminder, your membership helps to make our mission come to life. If you're not currently a member, we offer a variety of different membership options. You can view our new membership structure that was just unveiled this year on our website at nisma.org. For those interested in sponsoring NISAW in a bigger way, our new Premier Partner program is designed for you. Our Premier Partners enjoy benefits throughout the year, including acknowledgement on our website, at events, and connecting with the greater invasive species community. I'd like to acknowledge and thank our current 2025 Premier Partners, whose generosity made NISAW possible, as well as other NISAW programming. All right, now for our main event for the day. I'd like to introduce Mara Cunningham, NISAW's Government Relations Manager. Mara will be moderating our webinar today. Mara?
Hi, thank you. Hi, everyone. Thank you so much for joining us. As Christy mentioned, I am Mara Cunningham. I'm NISAW's Government Relations Manager. I'll be helping moderate this session today. We'll be hearing from the Army Corps of Engineers on their biosecurity initiatives. We'll be hearing from a slew of talented agency leaders. And first, we'll be starting off with Brianna Treichler, a natural resource specialist at the Army Corps of Engineers. She'll be presenting on the Corps' leadership structure. Brianna, if you'd like to share your slides now.
Okay, so I am Brianna Treichler, as we said before. I'm a natural resource specialist and park ranger out of Blue Marsh Lake for our Philadelphia district. And I am currently the new invasive species leadership team chair, and I'm a representative on that team for the North Atlantic Division. There we go. So as I'm going to be giving you guys kind of an overview of the Corps of Engineers and our program. So just a brief history about the Army Corps of Engineers. All the way back in June 16th of 1775, the first engineer of officers was appointed by George Washington. during the American Revolution, and that's really where everything started. Moving forward into the 1800s, the Corps of Engineers was established as a separate permanent branch of the Army, and then essentially worked with building our coastal fortifications, surveying roads and canals, eliminating our navigational hazards for different transport and shipping channels, explored and mapped the western frontier, and then constructed monuments and building in the nation's capital. The Corps became a lead federal flood control agency in the 20th century, and that's when we really started to expand our civil works activities and becoming a major provider of hydroelectric energy and the country's leading provider in recreation. A big change to our missions was in 1941 when we were assigned the military construction missions to build facilities not only here in our nation, but also abroad to support the U.S. Army and the Air Force operations. In the 1960s, we became a leading environmental preservation and restoration agency. And now with that, since we've done that, we carry out natural and cultural resource management programs at all of the water resource projects across the nation that we still operate. And then present day, we just continue to support our country's military and those water resource needs. This is where we are. We're pretty much everywhere across the United States here. We have multiple districts and divisions is how we're broken up. And within that, we also have our international operations in Europe, the South Atlantic, kind of down in like South America, also out in Asia, and the South Pacific region area. We're pretty much broken up mostly through watersheds or watershed systems. If you look over on the East Coast, you see Philadelphia District. That's my home district that I operate out of. And we're, for example, we're the Delaware River watershed, and that's where our operations are encompassed in. So that's kind of how we're broken up. But as you can see, we're a very broad agency throughout the nation. So we have a pretty extensive recreation program, and that's because of those water resource development projects that happened way back in the day. So we pretty much operate over 400 projects across 43 different states, and 90% of those are within an hour of a metropolitan area. You can see we've got a broad view of statistics here on this slide, talking about our recreation and those impacts essentially across the nation. We've got projects all over except for right around Utah, Nevada, Wyoming, and Maine. We don't have those water resource projects, but all those little red dots pretty much represent those recreation projects that we have. We have millions of visitors that come to our projects, and with those visitors, we generate a lot of revenue within those programs. These are all 2023 statistics that I was given for this presentation for these purposes today. But we host a wide variety of activities such as camping. We have day use areas, boat ramps, biking and hiking trails, wildlife watching, a wide variety of recreational opportunities for people across America. And then with that, again, revenue that's generated just from that visitation, there's a lot of visitor spending within the local area. So continuing to generate revenue for those local economies and supporting jobs within those areas. So you can see we're pretty comparable to the Forest Service and also the Park Service in terms of our visitation. Again, we are constantly kind of trending upwards there, and we're competing with the other major land resource management agencies, with the Forest Service and the Park Service. So with managing those recreational resources, what we have is a pretty extensive environmental stewardship program. Those programs are utilized to pretty much protect, preserve, and restore significant ecological and cultural resources at those civil works projects across the nation that we just kind of looked at where they're located. And the efforts contribute to the quality of American life by managing and conserving natural resources consistent with ecosystem management principles and provide a sustainable environment for future generations. So you can see we do a lot in terms of being able to manage different federally listed species. We've got about 426 projects or species, I should say, that are monitored and managed, over 352,000 acres of environmentally sensitive acres in areas that we're protecting, 5.3 million acres in waterfowl use. 7 of the top 10 migratory board flyways all cross over our project waters throughout the nation, and we are able to provide 14% of the U.S. freshwater fishing resources. Over 65,000 properties are outgranted for use that require our oversight. So those are properties that are maybe leased to state or other federal agencies, local agencies, and maybe sometimes some private agencies that are essentially utilizing that land for their benefit and not only the public's benefit, but we are overseeing those operations through those leases. And then we have a pretty extensive shoreline dock program throughout all of our water resources because people like to go boating. So we have that program as well. And then protecting our cultural resources across the nation. So with all of that, pretty much we have invasive species management that comes in tow with our environmental stewardship program. So we implement the latest and greatest efficient technologies and research for the management of invasive species, again, to conserve and protect and restore those public lands and waters throughout our water resource projects. 2 major programs that we run are the Aquatic Nuisance Species Research Program and Aquatic Plant Control Research Program. Those programs help develop new pest control techniques utilizing those biological, mechanical, or chemical methods. And we follow the U.S. Army Corps of Engineers Invasive Species Strategic Plan, and outlined there are kind of our main points. So prevention, we're looking to find cost-effective ways to prevent the introduction and spread of those invasive species across the nation, essentially, not only our lands, but within neighboring lands. We work a lot with the Early Detection and Rapid Response Program to, implement that coordinated set of actions to find and eradicate the initial invasive species infestations before they spread or cause harm, and avoiding those long-term costs and the economic burden that the invasive species cause. Following that, we implement control, eradication, and restoration management. So control and, when possible, eradicating established invasive species populations while promoting the use of native species in that ecosystem restoration is one of those core pillars within our strategic plan. And we coordinate and cooperate and work strategically using all of USACE's scientific management and partnership resources in unison to essentially manage those invasive species. And we collaborate across the Corps of Engineers and other entities to optimize operations through leveraging partnerships, educational efforts, and our funding. We provide a lot of research and development opportunities. We utilize science-based decision support tools and determine which species are likely to become invasive and their pathways of spread, as well as implementing and developing those best management practices to focus our resources the best way that we can. So again, that kind of goes to speak towards those efforts of that Aquatic Nuisance Species Research Program, the Aquatic Plant Control Research Program out of the Engineering Research Development Center that's located in Vicksburg, Mississippi, as well as some other satellite locations throughout the nation. And lastly, we're working with communication, education, and information management to effectively communicate the importance of invasive species management. That's what we're doing today, is we're talking about these things. We're trying to communicate the problems and also solutions, the importance of prevention, control, eradication, that early detection and rapid response. And we're trying to promote that to the public, our partners, and other stakeholders alike. So you can see down on the left-hand side of the slide here is kind of a little timeline. So this is really the development of invasive species management for the Army Corps of Engineers. So back in the 1880s to 1890s, water hyacinth actually became pretty expansive down in the southern part of the United States, and it was causing major problems, impeding commercial river traffic and operations, pretty much blocking up entire waterways. And so right around 1899, Congress got together and they were like, hey, this is a big problem. We need to fix this. And the removal of aquatic growths, or RAG project, was included into the Rivers and Harbors Act of 1899. And with that, the Corps of Engineers was essentially tasked to really tackle that problem through that project. So then in the 1930s, we began to start doing the first surveys of those plant populations in Florida, again, looking at that water hyacinth. And really that made us one of the first, well, the first federal agency to treat and be looking at invasive species management. And then in 1938, we started those plant control operations, again, of the water hyacinth right on Lake Okeechobee. And then following that, what is that, about 30 years or so later, in 1965, it was signed into public law 89-298, and that created, excuse me, the Aquatic Plant Control Program. So that federally authorized the Army Corps of Engineers to really start funding that program. And again, for us to be the first federal agency to treat and work with invasive species management. Again, looking at some statistics back in FY23, we pretty much were spending, or the cost, I should say, to the Corps of Engineers with a little bit more than $310 million for invasive species management. You can see how that breakdown, a lot of it, almost 75%, is really that prevention and control of those invasive species, and then starting to prioritize more the early detection and rapid response. And then we have a few other items that make up that cost. So, you know, our restoration, our research, that education and public awareness, and our essentially coordination efforts into the invasive species management. We can't really do invasive species management without partnering. We have a very large partnership program in the Corps of Engineers. That program makes us successful. We have over 3,000 partners across the Corps, and those projects, and throughout 304, about 72% of our civil works projects. So again, those water resource development projects that we have. A little bit over 42,000 volunteers. They make up a huge part of our workforce and help us do a lot of work on the ground. They're able to, their efforts are valued at about $54.5 million, which actually equals about 825 full-time employees. So they help us do a lot of groundwork that we're able to not necessarily do without them, or with fewer resources. An area of notable partnership focus is the management of invasive species, as I had said. And over 200 invasive species are documented across Corps projects, and they negatively impact all of our mission areas, whether it's recreation, environmental stewardship, water quality, navigation, our water supply missions, you name it, they're being impacted. Hydrilla, giant salvinia, and water hyacinth impede navigation. Invasive grasses threaten native prairie and add dangerous fuel to wildfires. And then zebra and quagga mussels have the ability to disrupt the generation of our hydropower. So the Corps has been working to implement, highlighted here, the watercraft inspection and decontamination program, as authorized through various WRDAs, which are Water Resource Development Acts, through a 50% cost share with non-federal sponsors. Typically, those are eligible states, and the focus of that effort is the interception of zebra and quagga mussels, foul vessels as they enter bodies of water, along with different monitoring, sampling, and rapid response efforts. And currently we have agreements of efforts throughout different river basins, primarily towards the western part of the United States. And we have more opportunities to be able to enter those agreements along the national border. I know that Jonas, who is one of the other presenters today, will speak more to that program a little bit later on. So with the Corps of Engineers being such a big and broad agency across the nation, we have essentially developed the invasive species leadership team. So it was noted that this is such a broad program across a broad area that we needed the ability to be able to coordinate our efforts. And so back in 2005, there was a memorandum that put out that we should put together a team of people to help provide oversight of the Corps' invasive species management program, and hence the ISLT was born. And what we are is we're a group of people, 25 people to be more specific, that consist of representatives from our major subordinate commands. So those are those divisions that I was kind of talking about that our individual districts make up across the nation here. And they're from within our operations and planning communities. And generally it's one person from the division office level and then another person at the district office level within those MSCs. So we have kind of like your big picture and then your more finite picture people coming together and being able to represent their divisions on this team. We also have a number of headquarters proponents that are on there as well that help us kind of communicate our needs for the invasive species management program upwards to that headquarters level. And then a variety of liaisons from that ERDIC, the Engineer Research and Development Center, the Armed Forces Pest Management Board, and the Interagency Working Group on Harmful Algal Blooms and Hypoxia Research and Control Amendments. So we've got a nice picture of our little kind of, I guess, business card, if you want to call it that, with some information about the website you can go look at in terms of the Corps' specific efforts towards invasive species management. There's different things that are highlighted on there. And then I have a nice picture of our team when we met out in Montana this past fall to essentially get together when we're talking about our different initiatives, what we're working on. We have a variety of subcommittees where there's targeting specific issues such as harmful algal blooms, education and outreach, policy, all that good stuff. But we get together in one place and we're able to work together on those different management initiatives. All right, so our main responsibilities on the team per our program management plan is to provide recommendations to those headquarters staff representatives on fulfilling our agency duties under different acts and executive orders, and to follow our invasive species policy from back in 2009. We provide strategic direction to the core research programs that address those invasive species, including that aquatic plant control research program and that nuisance species research program as well. We represent the Corps on our regional invasive species councils, so we're attending those meetings. We're talking with partners on those regional invasive species councils so that we can bring those problems back to the team and be able to see where we need to focus those efforts appropriately. We coordinate and collaborate with the regional invasive species councils across federal agencies and with non-federal sponsors, and then develop implementing cost-effective strategies to address the problems that we see affecting our different water resource projects and our environmental stewardship missions that we strive so hard to pretty much facilitate on a daily basis. And then we coordinate our team initiatives with environmental and other relevant U.S. Army Corps of Engineers community of practices. And then we coordinate annual cost information and provide that to the National Invasive Species Council via that Engineering Research Development Center. So these are our main responsibilities. These are the main things that are core values and items that the ISLT focuses on when we get together and when we're working on those subcommittees and striving to accomplish various action items. This is our current sitting team at this moment in time. So as you can see, we have multiple divisions throughout the Corps of Engineers. And we have those 2 representatives, except for the Pacific Ocean Division. It's a little bit smaller in terms of the operations and planning and what those resources are there. But again, we still have representatives from across the country, and we get together and talk about problems together. We've got our headquarters representatives, those engineering research and development center, those major programs, that aquatic plant control and the nuisance species research programs are there, and they help give us advice and expertise when we're talking about problems and about ways to figure out different solutions. And then again, our other Department of Defense liaisons from that Armed Forces Pest Management Board, and then from Big Army itself. So that's pretty much my whole spiel for you guys, really just giving you a background of who the Corps is, what our programs are, who we are in terms of the grand scheme of invasive species management. And as I mentioned earlier, we've got really great people that are going to be talking to you about some really cool projects. The NISAW team did a great job of giving an overview of who they are, and that you'll be hearing from them today. So again, you'll hear from Ben Sperry on the Connecticut River hydrilla control technology program, Chelsea Bohaty from our Jacksonville district, specifically talking about alligator weed and flea beetle program, Jonas Grundman, who is our technical lead for the aquatic plant control watercraft inspection and decontamination, or WID as we like to call it, program in those activities, and then Jessica Spencer, who's going to talk about some rapid response to giant salvinia. So that's pretty much it for me. I'm just going to stop sharing. So give the control back over to you guys.
Great. Thank you so much, Brianna. That was great. Next, we have Dr. Ben Sperry, a research biologist and leader of the U.S. Army Engineer Research and Development Center's Aquatic Plant Management Team. He'll be presenting on research and development for addressing hydrilla invasions in the United States. Dr. Sperry, whenever you are ready, go ahead and share your slides.
Well, thank you for the introduction, Mara. We'll get into the presentation. Just a note, mine will be quite a bit more research focused, as one case example of just a single species here, hydrilla. But for the audience members that are dealing with this plant, they know the seriousness of it. And those who are not yet dealing with hydrilla, count your blessings, because it's a tough one. So just looking at a little bit of background on the species in general, it is a submerged exotic plant to the U.S. And today we have 3 distinct genotypes in the U.S. And these introductions ranged, or they started back in the 1950s with dioecious in Florida. Currently, we have only the female of the dioecious variety, and that was followed by monoecious hydrilla in the 1980s, introduced in the Potomac River, and then most recently clade C hydrilla that we're currently trying to figure out here, that was introduced in the Connecticut River. Major impacts of note here. It poses significant impacts or impediments to navigation and access, as well as flood control, hydropower, public safety, as well as recreational use of aquatic ecosystems, and poses significant impacts in terms of fish and wildlife habitat and water chemistry. So this map really shows the spread of these different biotypes or genotypes of hydrilla. This was last updated in 2020, so 5 years ago. And if you can see here, the orange regions, that is the dioecious that was introduced in the 50s in Florida. So as you can see, nearly every county in the state of Florida has hydrilla established in it, and over the years has spread across the entire Southeast United States, as well as some introductions out west. and has been eradicated in several areas in California as well as the Midwest. Again, in green, this is the newer introduction, Monoecious hydrilla, showed up in the 80s. And as you can see, pretty consistent in that northern tier section of the United States, and is continuing to spread up into the Great Lakes region and poses a considerable threat into those states up there. And then most recently, again, is this Clade C hydrilla, which is this tiny little gray patch up there in Connecticut, Massachusetts, that showed up on the Connecticut River. And I'll be focusing on that specific genotype in some case study information later on. But a little bit more background and that's common in all of these biotypes is we've found out that it is highly adaptable to varying growing conditions, and that goes for all of the biotypes so far. In other words, there's not really a freshwater system type that this plant will not establish in and cause problems. And what makes it very, very difficult from an invasive species management perspective, is its ability to produce subterranean turions, or you'll hear them called tubers. And these structures are essentially compressed stems that can survive for multiple years, often in the sediment. And short-term management interventions look very successful within the same growing season, and these reproductive turion structures are what makes you hit the reset button year after year. So it takes a long time to start beating the population back to introduction levels. And also, since this species in particular is widespread in public water, there's a lot of nuance to how it can successfully be controlled and what we define success as. So we've seen a lot of different management strategies across the country that are dependent on the goals, budget, available tools, and permitting restriction, as all of those change region by region or even state by state, depending on in the country, where at in the country you are. And this photo here on the bottom left, that is one of the hydrilla tubers that I'm referring to. And for those who haven't seen the full extent of what hydrilla looks like at peak growth, here's a backwater slough area that's infested with dioecious hydrilla on Lake Seminole in Georgia. And it is, as you can see, all the way from the substrate to the surface of the water. And we were in airboats, but a typical prop boat has a hard time making its way through an infested area like this. So relating this back to, or in the spirit of invasive species awareness, one thing that is common amongst a lot of invasive species, but especially important when considering hydrilla management, is the difference between eradication and management. So because of the high growth rate, the spread potential and spread rates, as well as the persistence of this species, most of the time we message that eradication programs are largely unrealistic and usually unsuccessful unless extreme measures are taken. Versus most of the time, whenever a program of some sort for management is initiated, we like to align the focus towards a long-term management program. And that takes a lot of time and a lot of effort to develop. And essentially what it turns into is an effort to mitigate spread of the population and reduce its negative effects. But you need that management over a long course of time before eradication is feasible again. And I'll just reinforce that with the invasion curve here. So I think everyone would be familiar with these stages: prevention, eradication, containment. And then depending on where you look at it, this one in this case is called asset-based protection and long-term management. The reason why I bring up eradication versus management is because most of the time when hydrilla is found in a system for the first time and management efforts get underway, experts are called in and we give advice, we're usually up here on the invasion curve. So we're past prevention and eradication in terms of a feasible goal. Also, you got to think too, when you have an invasion level that's all the way on this end of the invasion curve, uh, we're reminded of control costs. So, in order to really appropriate enough dollars to handle an invasion of this scale and get it back down into the eradication level is very difficult just from a public entity perspective. So that's enough background. I'll get into some more research-based case study examples in this section, and this will be focused on that new clade C hydrilla that was found in the Connecticut River. And you'll hear me say clade C or Connecticut River hydrilla interchangeably. I haven't really trained myself to pick one or the other yet. Regardless, it is a genetically distinct clade or population of hydrilla that the best to our knowledge we've seen that it was discovered in 2016 in the Connecticut River. Like the other hydrilla genotypes, it rapidly spread and started impeding navigation, recreation, and all the other harmful things that it does. Also, dealing with this new, essentially a new plant to the U.S., there was no applied research conducted to date when the Corps of Engineers got involved. And to add insult to injury, there was no public hydrilla management program in the state of Connecticut, or a state agency that was actively conducting any kind of aquatic weed control. So we really lacked a state partner there from the beginning. And as everyone on the call, I hope knows, is one thing with invasive species is you need to conduct management to maintain the uses of the infested systems. In this case, it was the local economies that are so dependent on the Connecticut River watershed. So here we are, new problem and no proven solutions available. Well, let's talk about the site that it showed up in. So it couldn't have just been a pond or a small creek. It was New England's longest river. The Connecticut River ranges 410 miles all the way from the Canadian border to Long Island Sound and is comprised of approximately 7.2 million acres, all from that's the total acreage. I'm not sure exactly how many inhabitable acres there are, but essentially the entire state of Connecticut, every backwater, tributary, pond, creek that was connected to the main river is infested and is currently infested with hydrilla. This system also has a very diverse user base and consequently has been estimated to have an annual economic impact of over $1 billion. So very, very, a lot at stake economically there. And in terms of dealing with an aquatic plant, this was a challenging system to try to think through management on because it has variable or seasonal flow rate changes. And as you get down into the lower sections in the state of Connecticut, it is tidally influenced. So a lot of sloshing back and forth of water. So this gets into my comedy section of the talk here, but we thought right off the bat we were going to be able to hit the easy button and just spray the hydrilla out like we do any other aquatic plant, right? Well, let's look into that further. How we make a herbicide work boils down to 3 simple steps. We have to apply it at the right time, apply it on target, and apply it at the right rate. Well, for most herbicide uses, mainly terrestrial systems, this boils down to spray it when the weeds are present and susceptible. Don't miss the target or spray other organisms. And then lastly, to apply it at the right rate, that's simply calibrating your application and mixing it correctly. And it turns out to be something like this. This one of my colleagues, Dr. Enlow, so I hope he gets to see this at some point and me poking fun at him. But it is fairly simple in a terrestrial system. This is what it looks like. However, it changes a little bit when we talk about how to make an aquatic herbicide work. So instead of following those three steps simply for terrestrial weeds, now we're looking at applying at the right time is based on that plant's phenology. And since we're dealing with public water, there's a lot of Endangered Species Act compliance and local and state regulations, especially in the New England region. Step two, applying it on target. For submersed applications, we have to account for bulk water exchange rates. And as I mentioned before, in the Connecticut River, we're dealing with not only river flow, but the tidal influence on that tidal cycle. And then step three is applied at the right rate. Unfortunately, submersed plants live in this three-dimensional environment where we can't just spray over the top of them. So we have to understand what's called a concentration exposure time relationship, both of the target plant and individual active ingredients, as well as the selectivity components of the native plants that we don't want to harm. And it takes the form of this picture where we have to use operational equipment, get into large areas and test this at scale. Problem was with this particular case, much of these requirements were unknown, hence why we had to go to the drawing board, determine the data gaps, and initiate some research and development. So this bleeds right over from how to make herbicides work effectively and provide control for this new plant. The data gaps really boil down to having an understanding of the growth and reproduction of this new hydrilla biotype across many different types of environments. Not only for the Connecticut River watershed, but we have and we are currently considering this as a threat to the rest of the United States' freshwater resources. Again, we needed to understand the water exchange dynamics on a site-specific basis in the Connecticut River and align those potential treatment application windows in conjunction with what we call phenological weak points in the plant's life cycle to be most effective. And then lastly is just simply identifying the most effective and selective chemical control strategies. And that was the initiation of a slew of small scale research where we were testing different herbicide application or active ingredients from on the shelf registered products, different application rates, exposure time requirements, and techniques for these challenging environments. So what this is called, or what we took in this case, is an applied research approach with the overall goal of developing environmentally compatible control strategies that are based on science and can be implemented rapidly. And as a research scientist, that's the fun stuff. That's the challenge and cranking out all of the research data to provide the answers. However, in this project, because it was essentially being conducted and is currently being conducted in a fishbowl, so to speak, with a lot of public stakeholders and political interests, we had to also simultaneously initiate an education and outreach program to, effectively communicate what was going on, what the issues were, and proactively educate the public and other local agencies on the process that we are developing. So what the technical approach looked like diagrammatically is this, and it's systematic. So if we can look left to right here, we have the A, B, and C pillars. These are those three main technical questions that needed to be answered before we could get to a field usable technique. Again, A was understanding the problem, which is understanding this new hydrilla's phenology or its reproductive and spread patterns. And then matching that up with step B, which was understanding site-specific water exchange processes and rates. We did those through tracer dye studies. And then in this last step C, this is the small-scale work related to understanding the most effective herbicide treatments that can be implemented. And all of those information and data from those studies got funneled into field verification study level. So that's where we compile all of that, did that in 2024 actually, and informed operational scale field verification studies. And then after that step, we basically have a decision matrix that says yes or no, whether that particular field tool can be moved on to operational guidance, or do we need to refine it more and make it work better? And that's what we call this R&D feedback loop, which should, this isn't just specific to this particular hydrilla project, but is very critical in any operational development program. So with the time I have left, I wanted to walk everybody through just those initial research objectives and some of the things that we're finding, and kind of show you how all of that data fits together in the real world. So back to plant phenology or the life cycle research. This is where we were recording major reproductive and growth events on a site-specific basis. In this case, actually having to go out to these different sites in the Connecticut River and understanding how that species is growing on a month-to-month or even some cases weekly basis, depending on environmental conditions, with the sole focus in mind that we wanted to pinpoint an application window that would be a weak point in that life cycle that we could capitalize on for management. And what we found here, just as an example, is, on these left-hand graphs, this is data from field core collections and sediment core collections and various vegetation surveys. Is up here on this top graph, we have the vegetation hitting the water surface by July. So that is a good indicator of when it's going to be problematic on the environment. And in terms of tubers and turion production, those really start to peak in September, October timeframe as the day length goes at or below 12 hours. So that informed us that we needed to have application windows occurring sometime in that June, July, early August timeframe at these different sites. Moving on to the other step in the R&D process was the herbicide concentration exposure time studies that really we were somewhat starting from scratch with. I mean, we didn't have to go out and find new active ingredients per se, but there was a giant question mark as to what we did have registered, whether it was going to work or not. And this approach is also systematic and tiered. So what I mean there is we move in terms of research scale from small beaker level assays up to mid-level and then large tanks, constantly screening out potential treatment. So in other words, if it doesn't work at the lab bench scale here at a small scale, that treatment doesn't get to be evaluated at a mid-scale or large scale. And what this does, it allows us to replicate and screen the most effective projects with products or treatment regimes that have the highest success potential once we get to that field scale. And then for water exchange, this had to be done on site as well. And we learned very quickly that it was site specific. So just because you treated one area on the Connecticut River, you go across the river and a similar type site would act completely different. And that largely had to do with the tidal influence and the morphometry of these sites. But to break it down simply, all we do is put a fluorescent tracer dye called rhodamine in the water, and it acts in terms of physical dissipation, acts exactly the same as all of the aquatic herbicides that are registered. And we were able to regress those data and basically calculate hold times in the sites. So this step really coincides with those small scale CET studies, because once we know how long we can hold a product in a treatment site, we match that up with the exposure time requirement of a particular herbicide. So seems straightforward, but of course, as soon as we start to get those efforts underway, I talked about working in a fishbowl. Here it is. The next thing you know, we're being mentioned in the New York Times. We're on the local news. This is one of our contractors putting the dye study out, and they had a helicopter flying over taking video of it. And Senator Blumenthal was conducting press conferences on the river on our site. So it's an important thing to bring up, because that's a lot of pressure for being successful in a project like this. So we really needed to make sure we had our ducks in a row and we're operating based on the best information available. So we finally got to the field verification stage or field demonstration stage, and we're able to get 5 representative field sites treated in 2024. And as you can see here, these are the different sites and their sizes, the different herbicide actives we used, and the rates and their treatment dates, as well as their times. I put this slide up there so that everyone can see the specificity of each prescription at each site, right? So this is not like a terrestrial, invasive grass treatment where we can just say we're going to spray everything with imazapyr and expect the same result. We really had to tailor each one of these prescriptions to each site depending on how the water moved, how the plants were growing and progressing throughout the growing season in that site, as well as the native plants that differed from site to site and what selectivity we were desiring in those various sites. And then after we get those treatments out, essentially it's time to quantify the results of the field applications, which essentially boils down to documenting both the target and non-target plant responses, a lot of herbicide dissipation work shortly after treatment to understand how long we actually held herbicide concentrations so that we can relate that back to our small scale herbicide studies. And ultimately, we use these data to inform both future operations and, again, that R&D feedback loop, where if something went wrong or we didn't quite get where we wanted to be on the control front, we would just have to regroup and continue to fine-tune those prescriptions. And with all this level of planning, we were pretty dang successful. So just this represents some hydrilla abundance data and a few sites I wanted to show you that happened in the fall. So as you can see on this left panel, this is pre-treatment hydrilla levels. Darker red dots indicate denser hydrilla samples. And by a month after treatment in this particular case, we only had detections at lower levels in 2 spots. So that's what we were really striving for and want to see is getting all of that guesswork correct. Same thing here in this site, which was a very high use site, went from essentially full hydrilla coverage pre-treatment to just a few detections at very low levels post-treatment. And then again, I don't have to go through all of these, but this is just another example of the success there once you get to that field verification stage. And for the botanists that may be watching or listening, we also have been doing some background biology work with this new plant, and saw that this plant is very unique compared to what was into, basically gospel when it comes to hydrilla for years and years. So in particular, this plant so far is only producing male flowers, and we're kind of leaning towards it being a dioecious, from a different clade, but a dioecious male introduction. So we actually had some lab pollination or crossing experiments that we conducted just to see proof of concept. Is sexual reproduction something that is possible and potentially a new threat when it comes to hydrilla management, because everything up until this point has been, since the 1950s, to our knowledge, has been asexual reproduction. And lo and behold, we were actually able to artificially fertilize some flowers and produce hydrilla seeds. So I don't have the viability data yet, but this is why we explore outside of just field work, is to see what other components to a new invasion do we need to be concerned about and adapt our management strategies to account for. Also, just kind of a last data slide here. I had some work done with colleagues at NC State, and they also found that the turion sprouting requirements are much broader with this hydrilla biotype. In other words, it is able to sprout at lower temperatures and likely have a competitive advantage in northern tier states and get established earlier in the season. So just wrapping up here, again, this is kind of that approach or flow model on how we approach this problem. We have used this for other specific issues, and it seems to be serving us well. And I do want to reinforce here this R&D feedback loop. So just because this first step of getting that initial information is out of the way, once things go operational, you absolutely need that refinement stage and your researchers involved to answer new questions that come up. And just some reminders for aquatic plants in general, but especially hydrilla. The success criterion really requires initial and long-term third-party holistic research. It also is going to require environmentally compatible management tools. There are a lot of management tools out there, but they need to be assessed on their compatibility and efficacy in the field. Successful hydrilla control also requires vigilance and collaboration with a diverse project delivery team to be successful. And just another reminder there on that concept of eradication. And Mara, I will yield back to you.
Thank you so much, Dr. Sperry. Next, we're going to hear from Chelsea Bohaty, a biologist with the Corps' Invasive Species Management Branch. She will be presenting on the Corps' alligator weed biological control program. Chelsea, whenever you are ready, you can go ahead and share your slides.
Thank you. Thanks for that introduction. I really appreciate it. I am a biologist located in Jacksonville, Florida. I'm going to be telling you a little bit about our alligator weed biological control project. It's a little bit unique to our area, and I think you guys will find it quite interesting. I know we've heard some background already today about the Corps, but I think there's just a little bit of background that I want to give you just to make sure we're kind of all on the same page. So the Army Corps of Engineers has 3 main mission areas: flood risk management, ecosystem restoration, and navigation. Our branch within the Invasive Species Management Branch falls primarily under that navigation business line. We're authorized by Congress to keep federal waterways clear of several species of invasive aquatic vegetation. The one pictured here is water hyacinth, which was probably one of the most famous examples in our area of how bad invasive aquatic plant infestations can get, and how much they require management. So in order to keep our waterways clear, we use a strategy known as integrated pest management. This is a science-based decision-making process that combines several types of management. It combines biological control, cultural control, physical, and chemical control to manage risk from pests in a way that minimizes the economic risk and environmental risk of treating these plants and pests. We have a bunch of tools in our toolbox when it comes to choosing the right treatment option for an infestation or for a specific job. Biocontrol is largely known as the most cost-effective option, but unfortunately it does take years and years and years of research for an agent to be approved by the US Department of Agriculture. And the insects do tend to work really slowly because they weaken the invasive plant population. They don't really eradicate it because the insects inherently don't want to wipe out the population because then they wouldn't have anything to eat. So it's quite rare to find a feasible biological control agent that works for the management that you want. But today we'll be focusing on a biological control of a specific plant that used to cost the Corps millions and millions of dollars a year in chemical control, alligator weed. So alligator weed is a floating aquatic plant that is native to South America. It's a perennial species with two growth forms, aquatic and terrestrial. Both forms have opposite stalkless leaves that are about 1 to 1.5 inches long. The flowers appear in small little ball-like structures. They almost look like a little clover flower at the end of long stalks. You can, oh no, there's not one in that picture that I put. Nice job, me. But they're really small little flowers at the end of each of the stalks. In Florida, it typically reproduces vegetatively, which means if any piece of the plant fragments off of the larger plant, it can create a new section of plant from that. So it can get chopped up by, boats or carried along by currents or birds, machinery, you name it. It will be creating more alligator weed. So this plant was first introduced to the US in 1884 near Mobile, Alabama. It's thought to have been introduced from infested ship ballast water. And by 1963, an estimated 162,400 acres of US waters were infested. The plant forms really thick floating mats on the surface of the water, and they can inhibit water flow, make it super difficult for boats to pass through, and even displace native plants, not only on the top of the water, but underneath the water. So due to the quick spread and invasive potential of this plant, the Army Corps began funding research on possible biocontrol in the alligator weed in 1959. Again, I think I mentioned this earlier, but biological control agents are only approved for release in the US once they're approved by the USDA, and that takes years and years of research. I'm not going to get into the nitty-gritty of how that process works because it's pretty long, but from what I understand, it can take 10 to 15 years minimum to get a new insect approved for the United States. So in the 60s, several agricultural research science entomologists started in South America, started searching in South America for natural predators of alligator weed. And they found 40 different species of arthropod that fed on alligator weed to some extent. But of those 40, only 5 were considered important natural control agents for alligator weed. And of those 5, only 3 were found suitable for introduction into the US. And that is the alligator weed flea beetle, which you can see pictured, that beautiful yellow and black insect, the thrip in 1967, and the stem borer in 1971. For this talk, we're mostly going to be focusing on the flea beetle because it is seen as the most successful in our area. I'm sure there are areas where the stem borer and the thrip do better. In our area, we don't really see them very often. They were introduced, but I don't think I've ever seen the stem borer here in the St. Johns River system, but I'll see the thrips on occasion, but they're super, super tiny. So the biological control agent we're talking about today is Agoscles hygrophila, which is the alligator weed flea beetle. It is a small yellow beetle with black stripes. It's just about the size of your pinky fingernail, probably even smaller. Adults tend to emerge in the spring and they lay about 1,100 eggs during their lifetime. They lay the eggs on the underside of the leaves in 2 adjacent rows. You can kind of see that in the picture on the right where it's got those 2 little rows. It's a little blurry, but it's got 2 little rows of eggs right next to each other, and they're really, really tiny. You can see them if you like walk up to alligator weed and upturn some of the leaves. You can find them on occasion. They're usually yellow in color as well. There are 4 to 6 generations per year, and the last generation of adults overwinter among the roots and stems of alligator weed along the water body margins. So before I mentioned there were 2 types of alligator weed, both aquatic and terrestrial. The alligator weed flea beetle cannot survive on terrestrial alligator weed, only aquatic, because it really relies on that overwintering in the roots and stems beneath the water line, because that kind of protects them from harsh cold snaps. The life cycles of the beetle depend fully on that aquatic alligator weed, so it can really stunt their population boom if they run out of plants. So if they're really, really voracious eaters, so if they end up eating all of the population of plants, then odds are you're not going to have beetles the following year. Each year in the springtime here in Florida and Central Florida, thousands of alligator weed flea beetles swarm on the St. Johns River. Because they go dormant over the wintertime when it gets chillier, they all start to come back kind of all at the same time in the early to mid springtime. So because of this ability to overwinter in Florida, the insects really quickly established on the St. Johns and its tributaries, naturally keeping alligator weed at bay. So I mentioned this at the beginning of the talk, how the Invasive Species Management Branch in Jacksonville used to spend millions of dollars controlling alligator weed with herbicide. We have like countless books from like the 40s, 50s, like dating way back, where we can see that the Corps spent like so much money on alligator weed, even more than we spent on hyacinth and water lettuce. It was higher than that, which is wild. But once this beetle was introduced, in the 60s, that started to slowly go down, which is really, really cool. And now because of it, we at the Corps literally don't use any amount of significant treatment effort on alligator weed at all. Occasionally we'll spot treat things here and there, but our treatment cost for alligator weed using herbicide is effectively 0. Which is really, really cool. But since 1981, the Corps has been using these large swarms to conduct yearly flea beetle collections, which is about what I'm about to tell you about, which is really, really cool. We distribute them nationwide to other regions that need help naturally controlling their alligator weed infestations. But they're mostly focused in the southeast region. You can kind of see that on the map that I have on the left. But alligator weed has also kind of like crept into other mid-Atlantic states and some regions of California as well. So these are like common places that we tend to send alligator weed flea beetles to for support. Because the alligator weed flea beetle cannot survive the harsher winters of many non-coastal regions, a lot of other bodies of water throughout the US still struggle with the management of alligator weed. So because of this, we are funded every single year by the Aquatic Plant Control Research Program to conduct annual flea beetle collections, and that's been happening since 1981, to distribute the flea beetle throughout the southeastern United States. They're shipped annually by the Invasive Species Management Branch here to state and federal government agencies to be released onto properties that require management of this plant. So for the rest of the talk, I'll be telling you a bit about our alligator weed biocontrol program and how it's managed and run. So every year, the cycle of this program starts with surveying. So we start to look at our sites for the year right around this time, actually, in about February and March. The Jacksonville District's small craft operator crew, which is located out of Palatka. They play a huge role in tracking down the flea beetles each year. So we have a crew of folks who work out of Central Florida, Palatka, and they have an area of responsibility on the St. Johns River where they treat aquatic plants. And while they're out there, they are keeping their eyes peeled for any large amounts of alligator weed. So when I say large amounts, I mean big patches that are larger than 5 acres each. So they're looking for really big patches that are going to attract a lot of beetles. But as you can tell from these pictures, there are plenty of insects that look similar to the flea beetle. So it's really important to pay attention and know what you're looking for. Only the center image here is an alligator weed flea beetle. The other two are simply lookalikes. And I have gotten many messages from folks who are like, oh my gosh, I have so many alligator weed flea beetles, eating this plant or that plant. And I'm like, can you send me a picture? That's so interesting. And then I'll get photos of either this root weevil or a cucumber beetle instead, because they do look chillingly similar. So I'm going to tell you a little bit about our collection in 2024 and how it went. So last year, we collected on a couple of lakes throughout Florida. The main two that we collected on were Lake Dexter and Rodman Reservoir, which I have 2 green arrows kind of pointing to the general location of those areas. We ended up collecting on Rodman Reservoir this was the first time ever this program has collected on that area too, which was a really neat and unique experience because we don't typically collect over there. So when we're out there collecting, a lot of folks are like, well, how the heck do you get them? So in order to collect these insects, we get an airboat out on the lake. And we drive through these large patches of alligator weed, which you can kind of see in that bottom picture. It almost looks like we're in a field, but we're not. This is actually out on Lake Dexter, and it's a big floating aquatic mat of alligator weed. So you idle really slowly over this alligator weed mat, and you're going to take a bug net and swing it just over the tops of the alligator weed. And the insects will all fly up from the plants so that they'll get into your net. And then we transfer them into these styrofoam cups in a cooler that you can see in the top photo. We keep them over ice to keep them safe and chilled until we get back to the lab. So once we get back to the lab, all non-target insects, plants, alligator weed stems and flowers, so basically any reproductive pieces of alligator weed, are painstakingly removed by hand, leaving only flea beetle adults and larvae with some non-reproductive parts of alligator weed for food. This process is definitely challenging, and we have our entire team kind of helping sort out the non-target insects. But once we do that, the beetles are shipped in styrofoam cups. We try to estimate about 250 insects per cup, and they're packed into styrofoam coolers on ice. And then we ship them out to their new home. So shipping the insects on ice temporarily slows their metabolism, which ensures that they won't overexert themselves or run out of food during their postal service adventures. So in 2024, we caught about 40,000 beetles over the course of the summer. This is super average, as you can see from that green line going across the center. That's pretty much right on point for what we normally get. Last year was especially difficult to locate beetles. We had to spread out quite a bit to find what we needed. Usually when they're swarming, we can get quite a few all at once, but last year they really made us work for it. So, but as you can see by this graph, our record count was about 114,000 beetles, and that was collected in 2015. That was before I started with the Corps of Engineers, so I was not here for that jackpot of a year, but since that happened, we kind of wondered if perhaps collecting so many had a bit of a negative impact on the population, because as you can see after that, we had a couple difficult years in not being able to find them. I started with the Corps, or with this project rather, in 2019. So that was when I was brought on for this project. And we did have 1 year where we couldn't find any in 2023, but we think it could have just been due to really poor conditions, really high water, a lot of rain, things like that. So it really depends on conditions each year. But since 1981, we estimate that we've collected about 1.86 million beetles total. And those have all been sent to other state and federal agencies, which is really neat. So of those 40,000 beetles that we collected in 2024, we shipped to about 14 different agencies across 8 different states. You can see the map on the left there of which states we ended up shipping to. The highest number of insects were sent to North Carolina and Texas, with most of our shipments being internal to the Corps of Engineers. However, other agencies that received beetles included the South Carolina Department of Natural Resources, the Nature Conservancy of North Carolina, the City of Jacksonville, North Carolina, and Chowan University, among many others. So once the insects arrive at their new home, the staff members that they're sent to will take care to release them into their alligator weed infested areas. Here's some photos of folks who receive beetles, and they occasionally are kind enough to send me photos of their release, which is really exciting for me. Whenever these folks receive their insects, I recommend that they place the cups of insects gently on top of a mat of alligator weed and allow the insects to crawl out onto the plants on their own. Some folks would be inclined to shake the cup right out onto the mat. And despite living on an aquatic plant, the adult alligator weed flea beetles are not super strong swimmers. So if they fall into the water, especially after being on ice and in a cooler for several hours, they may not be able to climb back out of the water. So we strongly suggest to folks that they place the cups out on the alligator weed, do their survey or whatever else they have to do in that area for the day, and then drive back and recollect the cups on their way back to the lab. So these photos do show some of our partners at the Nature Conservancy, Chowan University, and other districts within the Corps of Engineers releasing their insects. We also support the lab studies of some of our partners throughout the nation by providing insects and keeping their lab populations genetically diverse. You can see a photo of a lab situation up in that center photo on top with some separated sections of alligator weed and flea beetles. So we have also been working on some outreach efforts over the past couple of years. For example, in the spring of 2023, I was invited to be featured on the Working in the Weeds podcast hosted by the University of Florida to discuss the alligator weed biocontrol program. If you're interested in checking out that episode, you can actually just scan that QR code on the right-hand side and it'll take you to the Spotify link. But if you don't have Spotify, you can just Google Working in the Weeds and scroll through their episodes and you'll find one that's called Alligator Weed Flea Beetle Highlight or something like that. It's really easy to find, but it was a really cool experience. It was a great success in getting some of the importance of invasive species management out throughout the state of Florida and beyond, which I thought was really neat. We also worked to create an outreach poster, which you can see on the left there, to send with all of our beetle shipments to help spread the word about availability, because recipients of the program often work with the public on the properties that are impacted by alligator weed. So the posters help communicate why the insects have been introduced to their areas, because I know a lot of folks often have questions about, well, doesn't that make this insect invasive if it's not from here? And isn't this plant or insect dangerous to my farm? Or, very valid questions that maybe folks who receive the insects wouldn't be as confident answering. So I put together a poster to kind of, be able to explain some of those questions a little bit more thoroughly. And finally, in 2019, we had the opportunity to collaborate with ERDIC to create a YouTube video about the alligator weed biological control project. So that was really, really neat. I have a link to it in this PowerPoint, but I doubt it's going to work because that's just technology. But if we have time at the end of the talk, I have it open in another tab and I can share it and we can watch it. But I'll just have Mara let us know if we have time for that. It's about 5 minutes long. So we're going to go over just a quick brief, like what I think would be my future plans for this project. Something that I think is a big gap in what I would love to know about alligator weed flea beetles is their efficacy. We know they work really well. We have seen before and after pictures of, an infested waterway with alligator weed. And then we know that the land manager put beetles out on their property and then voila, the plants were gone and the insects, did their job. But it's unfortunately, we don't really have a whole lot of data describing that accurately. At least I don't have it from our releases. So in 2022, we had a really cool opportunity with Virginia's Back Bay Wildlife Refuge, where they offered to help monitor their alligator weed management because they had an intern that was really, really interested in this project. So that intern started some preliminary monitoring efforts, and she did an excellent and consistent job of measuring beetle presence and abundance and plant density and the percentage of leaf area consumed. But the beetles, unfortunately, did not have very high survivability that year because they had just unrelenting rainstorms and cold weather in their refuge that year. So in the early summer months, the beetles just got really hammered by terrible conditions and they didn't do so well. And it was a year internship, I believe. So since then, we got her information and, we were able to get some of that really cool data from her, but I think we could have gotten better results if the weather was kinder to us. But all that to say, the monitoring plan will be passed on to whatever next intern comes by in the future at the refuge. And I'm really excited to see where it can go because I think it could really help us quantify efficacy for the beetle. It's really hard metric to measure because there's so many variables that can impact like the growth rate of a plant or the survivability of the insect. So we're really hopeful that as we continue to collect data on how they perform at more sites, we can kind of begin to better understand their overall effectiveness throughout the country. Thank you guys so much for listening. If you or someone you know in your area is interested in receiving beetles or they have a huge alligator weed problem, feel free to reach out. Here's my contact and I'd love to hear from you. And Mara, if we have time, I can show the video, but if you'd like to move on to the next presenter, that's also totally cool. And I can link the video in the chat.
Thanks, Chelsea. Yeah, I think if you want to link it in the chat just to make sure that we have enough time, that would be awesome.
Sure.
Thank you so much for your presentation. That was really great. Appreciate
Absolutely.
it a lot. Yeah.
Thanks for having me.
Yeah, absolutely. All right. So I think next we are going to hear from Jonas Grundman. He is a natural resource specialist with the Corps' cost share program for watercraft inspection and decontamination stations. He will be talking about aquatic plant control, watercraft inspection, and decontamination activities. Jonas, whenever you are ready, you can go ahead and share your screen.
Okay, so my name is Jonas Grundman. Like the slide said, I'm a natural resource specialist. I got to choose my own job title when I started this position I'm in now. And just the scope of work, I kind of chose National APC Program Technical Lead. So that's what you get when you don't have command and control of people. Sorry, just a joke, but yeah, I really help with our aquatic invasive species cost share efforts, particularly watercraft inspection station program that I'm going to talk about now, across the nation to the best of my abilities. I'd say 80 to 90% of my work is directly related to watercraft inspection and decontamination efforts. Yeah, so that's me. I guess before I really get started, I wanted to just take a moment to thank NISAW and everybody who supports and participates for the opportunity to speak. I love doing this kind of thing. A lot of my job is like presenting this material to our partners, to potential partners, to other entities who are interested. I really enjoy doing this. I really love the Q&A sections afterward. I love to talk about this program. So if you guys have questions, please don't be afraid. The worst that can happen is that I don't know the answer, and we can figure it out later. So when we get to that point, whenever it's appropriate, I'm more than happy to do that and encourage it. So what is the Watercraft Inspection Station Program? Why are we doing it? Why is the Corps involved in this? We're not operating stations ourselves, but as some of the other presenters alluded to or directly said, we're a water resource agency. That's what we do across the nation. And so every single component, every one of our missions, whether that's hydropower, flood control, water storage, water delivery, water-based recreation, environmental stewardship activities. I'm probably missing a few major missions that we have. Those are all missions that can be directly, negatively impacted by aquatic invasive species. And so that is why we're involved. And in particular with watercraft inspection and decontamination stations, this is really the Corps of Engineers' opportunity to get off of our own property, outside of our own boundaries, and to help facilitate a larger national, regional prevention effort, working with state and local partners in order to prevent that spread from moving to infested waters to uninfested waters, right? And so I'm excited to be a part of that. I saw zebra and quagga mussels as they came into my former district, Omaha district, when I was working there as a natural resource specialist, saw the impact to our hydropower facilities and our recreation components. So I am passionate about this, and it's something that, yeah, I wish didn't exist. I wish it wasn't a problem, but I am happy to hopefully be part of the solution. So we're authorized by the Rivers and Harbors Act of 1958. It's been amended numerous times, and I'll go into that. So before we get into too much detail, I'm going to give a real brief overview. You know, what is a watercraft inspection station? You know, you can think of it in a lot of different ways, I think, and there's a lot of different iterations that we see out on the ground when we're working with our partners. So essentially, like it is what it sounds like, right? It's any place where some entity who has like a jurisdictional authority is inspecting watercraft to make sure that they are not transporting or vectoring aquatic invasive species, materials that may harbor aquatic invasive species. You know, like if you have a mat of aquatic plants, the plant may not be an invasive itself, but it could be harboring something that is potentially invasive. You know, a dirty boat that's muddy, the trailer's muddy, right? There could be things harbored in there. And then, or standing water, right? That's another big one. Standing water that could be, you know, hosting veligers for zebra quagga mussels or things like that. So any place that people are inspecting watercraft, that is an inspection station. There's a lot of varieties that we see on the ground. We've got major permanent stations, all flag Washington State. They've got permanent stations on the interstate highway, you know, kind of an old way stations for trucks. You know, they have a few of these that are like permanent. I think they might be 24 hours, 7 days a week, 365 days a year, right? They're always staffed. There's always somebody there. You're required to stop. We have others that we help support that are more temporary in nature. We have some that are roadside stations along highways at key access points where we know traffic funnels and, you know, they get stopped there. We have roving stations that maybe just go on high use recreation days, and it might be more of an educational campaign, right? So that's might be what our partners are doing, and that's what we're helping to support. Something I try to emphasize is that we're not trying to, as the Corps of Engineers, dictate what a prevention program looks like for all of our partners. What we're trying to do is facilitate the improvement of those inspection station programs, support those, make them better, whatever it looks like on the ground, so that we can just do whatever we can to bolster those prevention efforts. A lot of our partners tend to be state agencies. I'll interchange terms. Really, we work with non-federal entities is the term I should use. A lot of those entities we work with are states, governments, or state agencies. But I just want to point out that includes partnering with local governments, county governments, tribal governments, First Nations, sometimes some NGOs, universities. So if I default to state, I apologize. I mean it in a more encompassing component. But essentially, yeah, we're working with anybody who has jurisdictional authority to enforce aquatic invasive species regulations or has a mission to do so. A lot of things can happen. It's supported by law enforcement. So a station may be run by the Parks and Wildlife, and then they get support from, you know, Highway Patrol to help chase down people who missed the boat. You know, the inspection station. It might be staffed directly by those employees, or it could be staffed by contractors or even volunteers. It might be mandatory. It could be voluntary. Depends on the state regulations where you're at. And so what happens if you show up to a watercraft inspection station and your boat's deemed to be either be contaminated or potentially contaminated? You know, a lot of these, it's not that big of a deal. They don't like to see it, but most of these places have some type of decontamination capability on site, or they can direct watercraft to a spot where they can get that boat cleaned. You know, in rare circumstances, they might be said, you know, they might put a tag on the boat and say, hey, you're not allowed to launch for a certain amount of time until it's dry. I've seen this kind of held and impounded is not something that happens very often at all. I think I've only really seen this when it's large industrial water-based equipment, barges, or other things that they have found, zebra or quagga mussels attached to. Those are usually complicated. They're hard to get at all the components. So they'll do a major cleaning of it, and then they'll want to make sure that that dries and those zebra or quagga mussels or whatever it happens to be has time out of the water to dry, to desiccate, so that it is not a potential vector when it's then put in the water at a later time. So that could be, a formal impoundment, or just, like a note, if you launch this, you're going to be in a lot of trouble. Don't put it in the water until whenever. And, I have a caveat here that these things really are dependent on the jurisdiction. They have different laws and regulations. A lot of regions, multi-state regions, are starting to, or have been, coordinating those, the legislative act that gives them their authorities. They're starting to, try to synchronize at least a regional scale, if not a national scale, so that there are similar regulations in place for that area wherever you go. I think that's awesome. It gets a lot of consistency across those regions, but it differs. The other thing we do, and it's not in the title of the slide, but this is really a 3-tiered program, or a 3-legged program, as I like to think of it. So we have the watercraft inspection and decontamination stations, right? The on-the-ground thing that they're doing to prevent that spread. The other 2 things in this program, one of them is our monitoring effort. So we support our non-federal entities with their early detection sampling, whether that's veliger, whether that's DNA testing, water quality sampling for like risk conditions. That's another thing that we're able to help cost share the effort of if they are eligible and authorized for the program. And we do this a lot. That's a big component of ours as well. The other thing that unfortunately we are starting to learn about, the 3rd tier of this, is rapid response planning. So if that preventative effort fails, the monitoring program picks up a new population of most likely zebra quagga mussels is what we're looking at. Then we can help support a state's rapid response action. We can actually help with their planning activities. So like the rapid response planning that they might be doing well before they have a known infestation. We can help with that kind of risk assessments, those activities, help reimburse for those, be involved, be at the table. And then when it comes time, unfortunately, if there is a rapid response, whether that's to eradicate or just to try and get containment, we can also help reimburse for the activities that our partners take on that. This gets complicated, especially if you're starting to get into chemical control, or you're starting to do dewatering of a small reservoir or something like that. These are things I've seen in the past. There's a lot of environmental compliance regulations that go into those activities. So it's a lot of back and forth with our non-federal to make sure that happens. And we're learning some lessons now after Idaho's Twin Falls response, but improving those processes. But we're there at the table, getting ready. Just a little bit about the program. I know this is a very text-heavy slide. I really just have this up here because I want to this is on the on the right-hand side. This is the bulk of the legislation that we are implementing with this program. I mean, if I am asked about this program, this somewhere in this language is what I'm going back to answer that question. We operate, it gives us our specific areas where we can provide support for watercraft inspection and decontamination stations. You can see Columbia River Basin, Upper Missouri River Basin. There's kind of a complex of basins here with the Colorado, South Platte, and Arkansas, the Russian River Basin in California. And then we also have an authority that was added in 2020 for us to do basins that intersect the border between the United States and Canada. So we can support entities who are doing watercraft inspection anywhere within that area. And I have a map that'll be coming up here shortly to kind of help describe that. And then really our focus is to keep these species from moving into or out of waters of the United States. And what that means is even though we're authorized to protect a basin, a drainage area, we can actually operate and help support stations pretty much anywhere in a state's geopolitical boundaries. So even though a basin may only intersect a component of that, we understand that having an inspection station outside of that helps prevent the spread into. So we support a state's efforts throughout their region, not just within the basin. And you can see the cost share effort here. It's a 50% currently. I have a little update on that coming up. And then you can see where we have our authority for monitoring and contingency planning as well. On the left-hand side, I'm not going to go through this. This has been a growing program. You can see the dates. In 2014 is when we got the initial authority for us to start cost sharing these activities within the Columbia River Basin, and actually just within 4 states. And the reason I have this on the left-hand side is just to show that we have had consistent changes or different guidance in the program, kind of expanding it, really positive things. But we have been a very sort of in a reactive state, as I call it, where we've had a change. We have to figure out how to implement it in the program, update our documentation, get everybody like up to speed, and then roll out. And we've just kind of consistently seen the growth of the program. And so we've been in kind of a reactionary foot for a while, just trying to get everything on the ground in the best way possible. Let's see. Okay, there we go. Yep. And now kind of a visual, you can see where we're either currently operating, where we're eligible to operate, kind of colored up here by basin area. We have states that operate in multiple basins, or it could be. We've just grouped them into one basin. It's simpler that way. I don't want them to have to split out their costs between the Missouri or the Columbia River Basin. It's not the way the funding comes in, so it's not really a major issue. So this is just the authority, like our NEPA documents, our reports that establish the program. This is how we kind of grouped everybody together. You can see in the box on the left, in some of these regions, we have states that are active. So I'm not trying to pick on anybody, just as an example, though, since I'm from Nebraska, in the upper Missouri River Basin, we've got North Dakota, South Dakota. They are in the program. They are submitting invoices. We're reimbursing for their activities. We have some states that are eligible. We've included them. We've scoped our program. But for a variety of reasons, they may not currently be in the program. They may not have one to begin with. So there's nothing to do. For Nebraska, it might be that they have a program and they currently, out of the funding that they receive from their state legislatures, is currently matched out with other program areas, right? So we're a 50-50. Maybe they're getting a better deal on their dollars with some other grant program for the scale of their efforts. And so it doesn't make sense for them to leverage against our dollars. So they could be getting, 75 cents for every 25 cents that they're expending, and we're 50-50. So that's usually what I've heard is a reason why states who are eligible are not currently participating. You can see all the areas that we're involved in. We're trying to stand up this U.S.-Canada Border Region Authority. Since we already have authorities for the Pacific Northwest and sort of that central tier of states, we are now, we're using that U.S.-Canada authority to kind of expand eastward and capture that Great Lakes region where we know there's a lot of source populations, and try and help support those efforts as a preventative to keep them from coming out. Changes. So I talked about changes a little while ago, and we have more coming down the pipeline. So the Rivers and Harbors Act, the Water Resource Development Act of 2024 amended our implementing or our authorizing legislation in the Rivers and Harbors Act, just like it has in all the previous ones. And so a couple of changes that we're tracking that we're going to have to somehow figure out how to get into the program are kind of listed on the left. The one that's really critical here is that second one, section 1361, which would actually modify our program to make it, instead of a 50-50 cost share, make it a 65-35 cost share. It's inserted in kind of an odd spot. It may mean we have 2 different reimbursement rates for our current program. I'm hoping we can work around that, but we'll see, just waiting on guidance on how to implement that authority, and then we will be able to roll out and hopefully start increasing the bang for buck that our partners are receiving through this program. Occasionally, so as part of our program, we're always trying to improve. We're trying to do better things, be more efficient. Congress has, if you're not aware, they have Congress has an actual agency under them called the U.S. Government Accountability Office, and it's there to help agencies find efficiencies, make sure that things that Congress has authorized are being done the way Congress planned and desired. And so GAO, as part of their routine activities, performed a review of the watercraft inspection station cost share program. It was a really interesting, fascinating, and positive experience to go through that with them. It was an interesting team. And through those conversations, and it's a very conversational thing, we came up with sort of 3 recommendations to improve the program. And I just have this slide up here to kind of talk briefly about that. That we're just doing a variety of things to help make better decisions, right? We're collecting better data so that it can inform our risk analysis and our decision matrices. We're updating guidance. Our implementing regulation is from 1996. We've obviously had a series of laws that have changed things. We've had different guidance that came out. So we're trying to update that guidance right now to better reflect what the actual program is for the aquatic plant control program. And then we're also developing a strategic plan. I think somebody else mentioned a broader strategic plan for invasive species management, but we're also tasked with developing something specific for the implementation of the watercraft inspection station cost share program. So that's ongoing and an effort that we're taking as well. Where are we at next? Oh, some like related research and projects. I love this. We get to do some really cool stuff sort of as a component of this program to help improve it. We're doing a watercraft movement study to help inform risk analysis using some pretty interesting techniques. Don't be afraid. I know it says anonymized cellular location data. This is stuff that's commercially available. We're not gathering the data as the government. It's we have a contractor who's doing that for us, and we're just seeing the results. But it's a really cool, novel way to look at how people move watercraft or move from water body to water body. Outside of doing like actual surveys with those boaters. So it gives us a great picture to either affirm or find gaps in the way people move so we can put stations in the right locations at the right times. We're doing cool stuff with genetics to look at cell line development. There's not a lot of great research out there. We're working with somebody doing that. We have some researchers doing microbiome study. This is a really cool, we know what the major factors are for zebra and quagga mussel establishment, calcium, things like that. But we've also seen where water bodies have an initial detection, but then a population does not establish. And so the purpose of this study is to kind of look at that and see if there's other microfactors that are if there's other environmental factors that are keeping them from establishing, and see what we can learn from there. If there's cool techniques to help support that risk analysis. Bunch of other stuff we're doing, all really cool that I like to do as part of this program. I'm kind of shifting gears just a little bit. Brianna touched on this a lot, so I'm just going to skim over it. It's something I started adding to my presentations, just kind of talk about where the Corps of Engineers intersects with aquatic invasive species in general. In this kind of diagram, red is sort of things that go directly to the Corps of Engineers funding-wise. It's used internally. Green is something that might be available to support an external effort or a research effort. It might go to a university, to something like that. And then the white is like, it's just sort of nebulous. It depends on the specific thing. But you can see that we do a lot of different things. There's actually a couple of program areas in here that I need to add into this diagram that I recently learned about. But yeah, we touched on, and the whole purpose here is to look at what we do and what our capabilities are, and then hopefully our state partners, our other partners, other interested organizations can kind of look at their matrix, and we can start connecting dots and boxes to each other and find ways to work together to build synergy and do cool stuff. And I'm happy to talk about any of this, but it's not the direct purpose of this presentation. So I'm going to skip over it a little bit. And Brianna touched on quite a few of these already. And then this is just a reference page if you're interested in any of those programs, links, a little bit more information. Cool stuff there. And that's me. So that's the end of mine. Appreciate the opportunity to talk and looking forward to the Q&A section.
Hey, thank you so much, Jonas. That was really awesome. We appreciate your time and your expertise. And last but not least, we are going to hear from Jessica Spencer, who is an invasive species biologist working for the U.S. Army Corps of Engineers in the Jacksonville district for the Invasive Species Management Branch. Jessica will be presenting on the rapid response to giant salvinia in the St. Johns River Basin. Jessica, if you are able, you can go ahead and share your slide.
So I am Jessica Spencer. I work for the Invasive Species Management Branch for the Army Corps of Engineers here in Jacksonville, Florida. And I'm going to be telling you about our rapid response to giant salvinia in the St. Johns River Basin. Our rapid response to giant salvinia, if you are not aware, giant salvinia, Salvinia molesta, is a federal noxious weed. It is a floating aquatic fern. It can form these dense mats up to 1 meter thick, so definitely causing a lot of impacts. The population can double from 1 acre to 2 acres in 3 to 5 days, which is astonishingly fast. It reproduces vegetatively, so luckily it doesn't produce fertile spores, or it would be that much worse. But that rapid reproduction still makes it very problematic in areas where it does get established. It will eliminate pretty much any open water habitat by forming that dense mat. It'll shade out any submerged aquatic vegetation that may be growing underneath it. And it is a floating plant, so it also clogs up water control structures. Some of the distinguishing characteristics, the leaves are very water repellent, so often you'll see the beaded up water, molecules on there. They have these dense hairs or trichomes. And one of the distinct characteristics is those trichomes on the surface of the leaf, the ends of them are shaped like egg beaters. So the hairs kind of split and then recurve back together. You can see it in that picture down at the bottom, how it has that egg beater shape at the end of the hairs. And as the density of the plant infestation increases, the leaves start to kind of fold up and form what I call like an accordion growth pattern. So you can see down there on the right how the leaves are kind of folded together like that. And that accordion-like growth, it is fairly unique. So if you see a plant that's folded up like this, odds are you're probably dealing with giant salvinia, but it's not consistent. So you may have giant salvinia that hasn't yet folded. So if you see it looking like these images here, odds are you've definitely got a problem, but it can also lie flat on the surface if the infestation isn't dense or if it's, under some sort of stress and not growing to its full potential. So we do have another species of salvinia that it could be confused with. Both of them are invasive, but the common salvinia or Salvinia minima is not nearly as aggressive as giant salvinia, so it's not listed on the federal noxious weed list. It does require management in some areas when it gets, a little more intense, but generally it's not going to form those thick mats. It's going to be, flat on the surface, and have generally smaller leaves. And the main way to tell the difference between the two is the trichomes or the hairs on the common salvinia are open and forked. So you can see in the picture on the right that, it just has those 4 kind of open branched leaf hairs, whereas the ones on the left for the giant salvinia show that egg beater shape. So, giant salvinia in Jacksonville. We were alerted to this population. Basically, there was a new contractor that had taken over treating the city of Jacksonville stormwater ponds. And they provided us with the picture that you see there with the boat on September 30th of 2023. They had arrived at this pond. It was completely topped out, covered over with this quote unquote salvinia. They reported it as just salvinia. but it was about a month later during the post-treatment inspection that the supervisors realized it was not salvinia minima, which would have been the assumption, because we do have salvinia minima pretty widespread throughout the St. Johns River Basin. It was actually salvinia molesta. So at that point, when they recognized what it was reported to the Florida Fish and Wildlife Conservation Commission, or FWC. They got that report on November 1st, and then they notified us the very next day, because it is pretty much right in our backyard. Our office building is on that little kind of nub that where the river gets really narrow, just to the northwest of the red arrow. So it was, you know, about 5 minutes from our office. So on November 6th, we were out there inspecting the pond to confirm the report. We did see salvinia still present. So we, you know, documented that, got some samples, got some pictures. And then on November 9th, we did a follow-up site visit with the City of Jacksonville employees, because you can see in the photo there, the salvinia plants were right at the lip of the outfall structure, and the outfall structure for that pond drains into a pipe that goes underground, and we did not have any idea where that pipe, you know, ultimately flowed, but the location was less than a mile from the St. Johns River, so we knew that ultimately that's where it was headed. So during that site visit on the 9th, we were able to get the City of Jacksonville employees to provide us with the, you know, maps of the underground pipes, to go follow that to an outfall ditch, where we found salvinia molesta in the outfall ditch, as well as the receiving creek on the other end of that outfall ditch. So unfortunately, it had spread. So this map shows that original location of the salvinia molesta stormwater pond, and then just to the north of there, that line where it says Craig Creek, that is this concrete lined outfall ditch that you see in the top right image. The picture just to the left of that shows the giant salvinia that we observed in the concrete ditch. That ditch then goes under the road. It goes through the backs of some neighborhoods, and then it pops out in this River Oaks Park, which is a direct tributary into the St. Johns River, which is the dark image, or the dark part of the map on the left. So the picture in the bottom left is an image of the salvinia molesta that we found in River Oaks Park in that tributary. So you can see in that bottom left image that this is not that folded accordion shape. It looks much more similar to the growth form of salvinia minima. So we did actually have to get out a hand lens and take a look at the surface of the leaves, and we did confirm that it had those egg beater hairs. So, you know, that was something that made us a little wary, because if, you know, if it's floating out in the river and it's looking like salvinia minima, are we missing detection of it in the river? So as I was explaining, that young or stunted giant salvinia looks very, very similar. So, you know, you have the picture of the giant salvinia on the left, which may be stunted by, you know, some slightly saline conditions that were in that creek. And then the common salvinia on the right, the leaves may be slightly larger on the giant salvinia, but honestly, it really takes looking at it under a hand lens to see the shapes of those hairs to be able to make that determination. So we knew that we needed to quickly respond, you know, and mount our rapid response. So luckily, we had a lot of agency cooperation. On November 16th, the Corps installed this boom around the outfall structures of the pond to make sure that there wasn't any additional movement of material out towards the river. November 17th, the Florida Fish and Wildlife Commission created a mailer with ID and reporting instructions that they sent out to the neighborhoods surrounding that area. You know, we weren't really sure what the source of the population was, so we wanted to make sure that people were aware of it, if there had been any sort of, you know, aquarium dumps or anything like that, to make sure that people knew that this was something that we did not want to have in our natural systems. So on November 20th, that was about a month after the original contractor, you know, had done their control, and we got our crews back out there. There was still some remaining green material. You know, the contractor's treatment wasn't completely effective, probably because it had already started to kind of stack on itself. So the Corps was able to get in there and treat the pond with flumioxazin at a rate of 10 ounces per acre, which is on the high end for flumioxazin. But again, with this being such an important, you know, critical thing to get under control, we wanted to make sure that there wouldn't be any remaining plants that we would have to deal with. So we did go in with a pretty hot rate. So on December 20th, we worked with the Florida Fish and Wildlife Commission as well as the city of Jacksonville to install this boom across Craig Creek. And so the intent was to make sure that any of that material that had gotten washed downstream, that we were able to catch it and prevent it from getting into the river. You can see that, you know, there's a lot of vegetation and, you know, grasses and things like that along the edges of the bank. So this creek does flood when there are storm events and, you know, kind of goes up onto the banks. So we wanted to make sure that, you know, if there was any material that was kind of hung up in the vegetation along the edges, that we were able to prevent that from going downstream. Then also in December, we worked with our Portland District GIS staff to publish a quick capture survey app. That's part of the ArcGIS you know, suite of apps that they have available. And we were able to set it up to be a very simple report to do presence absence for salvinia. We also launched our outreach efforts to educate other land managers, as well as the Lake Management Association, which is sort of a trade group that covers a lot of the businesses that do the lake management for golf courses and HOAs and all these other entities in Florida. We have a ton of stormwater ponds because we are so flat and often subject to pretty intense rains. So it is a large business group. So we were able to get in touch with them, and they were able to distribute the information out to their groups. I did run into some of them as I was monitoring and, you know, let them know, like, yes, we're looking for this plant. They told me they had heard about it, which was great. It's always nice to see that, you know, your outreach efforts are reaching the right audiences. So that was encouraging. This is the interagency app that we put together. It's actually open to the public. So if you scan the QR code, you should be able to access the app. Again, it was intended to be very quick and easy. It does not require a login, so you don't have to have an ArcGIS account. It is free to use it. You just download the app from the App Store. And basically, you just click one of these three buttons. You either have what you believe is Salvinia molesta, or you have a salvinia that's probably minima, but you're not totally sure. So we have a salvinia spa for the yellow and then no salvinia in the green. Click one of those buttons, it takes you to your camera. You're able to document it with up to 3 photos, and then you click submit and that's it. And it automatically gets sent to the cloud. I'm able to immediately access those points and, you know, see what people are reporting. So we were very grateful to have that and have the ability to have other eyes out there looking for this stuff. So the other piece of this was that the city of Jacksonville, they have 258 stormwater ponds that they're responsible for managing, and they use that contract that they have for the management of all of those ponds. So that was obviously something that we were very concerned as far as the potential for spread. You know, that original image had a picture of a boat on a trailer next to the totally infested pond. So we were concerned that there could have been a possibility for that Salvinia molesta to have been moved to one of these other locations. We did contact the contractor, and they actually told us that they had saved that pond for the very end of the month because their routine practice is to clean all of their equipment and decontaminate everything at the end of the month. So they, you know, kind of saw that as being sort of problematic. So they made sure that when they were done with that treatment, that they did clean everything. So that was great to hear. We were able to get that information for the locations of all of the City of Jacksonville stormwater ponds, and we sent our Army Corps folks out there to inspect each and every one of them, and we were able to confirm that there were no other locations that we were able to detect Salvinia molesta. There were a couple that had Salvinia minima, but we, you know, made sure that we checked the hairs on the leaves, confirmed that it was Salvinia minima, but we also made sure to revisit those ponds to make sure that there wasn't some explosive growth. Maybe there was 1 or 2 plants of Salvinia molesta mixed in that we didn't, you know, we weren't able to reach or, you know, didn't notice. But so far, knock on wood, all of those ponds have remained Salvinia molesta free. So that was wonderful. We also encourage EDMAPS reporting. So there were some other locations that we had found on the EDMAPS database. You know, we were trying to determine the closest locations where this Salvinia molesta had been reported. So that EDMAPS data allows you to provide a little bit more detailed information on the populations. It gave me some good resources to, you know, verify that it was in fact Salvinia molesta that they were reporting. It also sends alerts to all of the regulatory agencies and land managers. So because it is a federally listed noxious weed, it auto, you know, kind of alerts the folks that need to know when those things get reported. And then you can also set up your own alerts. So once, you know, this was kind of flagged as an issue in our area, I was able to set up alerts for any new records for Salvinia molesta and, you know, have EDMAPS ping me anytime a new report came in. So that was a really great resource, and we were happy to have all that information. We do still have some uncertainties. So, you know, we don't know how it got here. Is this the only population in the area? Has it spread potentially from this location? You know, the trickiness between determining giant salvinia or common salvinia, you know, when it is in those rougher conditions, they can look superficially very similar. So making sure that we're able to make that determination. And then, you know, the big question on my mind was, has it gotten established in the St. Johns River? We know that, you know, it was right there at the lip. we actually had a storm system come through in December, and it was unfortunately right before we got the boom set up, and that entire system got flooded, and it was, I mean, completely out of the banks. So I mean, I just know in my heart that anything that we had observed there that month before was likely washed into the river. So can it tolerate low levels of salinity? How long can it survive in those somewhat brackish conditions that were in the creek? All of these were things that we weren't really sure about. So as far as how it got here, you know, I don't think we'll ever know for sure, but the closest known populations, this is some of that EDMAPS data that I was talking about. It's over 150 miles away in any direction. So, you know, it's unlikely that it would have spread naturally. We did get information from the contractor that had just taken over the treatments that the previous contractor for City of Jacksonville had worked in Louisiana and Texas, where Salvinia molesta is a big problem. So there's, you know, some thought that perhaps that previous contractor had spread it on some of their equipment. There's the possibility that maybe it could have spread by waterfowl. It could have been someone dumping their aquarium. You know, is this the only population that we have? So we checked all of those City of Jacksonville ponds, but there's a ton of other ponds, like I was mentioning, whether it's HOAs or golf courses or, you know, road construction, the runoff for the roads, there's the ponds all over. So we needed to, you know, kind of check the surrounding areas and make sure that there wasn't some other repository that it could have spread from. So our other question, will brackish water kill it? So this is kind of a larger map showing the general location where we found the Salvinia molesta, including in the ditch as well as the Craig Creek or River Oaks Park. But you can see the Atlantic Ocean is over there on the right. The mouth of the St. Johns River is right there by Mayport. So this area of the river where it starts to get wide, where the Salvinia molesta was detected, that is still tidally influenced. So it is brackish water. The salinity levels in the Craig Creek area where we found the Salvinia molesta, those are a little bit lower at 0.5 to 0.6 parts per thousand. In the river itself, it's closer to 2 or 3 parts per thousand. So the river does have a higher salinity than where we found the plants. It's also very wide in that area. And the one benefit that we have is Salvinia molesta does not like big open water with, you know, rough conditions and waves and things like that. So our hope is that if plants were flushed out into the system, particularly if it was associated with a storm event, odds are the conditions would not have been ideal for the Salvinia molesta to survive. It would have gotten, you know, pretty beat up by the waves and rough conditions on the river. So between that and the salinity, we are hopeful that that was enough to knock it out. But as I mentioned, that salinity was something that we wanted to look into further. And, you know, the other concern with that is, as I mentioned before, the stunted or, you know, Salvinia molesta that had been impacted by those slightly saline conditions, it superficially appears to be the same as Salvinia minima. So, you know, that really makes the monitoring and detection much more difficult because it's not as easy as just looking at the plant from the bow of your boat. You actually have to pick it up and look at it with a hand lens. And then how do you properly sample if it's all over the river and ensure that there's not a piece of Salvinia molesta, you know, kind of hiding in plain sight among the Salvinia minima. So that was definitely one of the obstacles that we were dealing with. So we did reach out to the ERDIC, Engineer Research and Development Center with the Corps, as well as the University of Florida's Center for Aquatic Invasive Plants. And we did some water quality testing in Craig Creek. That was how we got the information on the 0.5 to 0.6 parts per thousand salinity. The preliminary research showed that exposure to various salinity levels for a short duration was not enough to kill Salvinia molesta, and I think they went all the way up to 15 parts per thousand. It was for short duration, so we're not sure if, you know, a longer duration would eventually kill the plants. That's some of the additional salinity studies that we'd like to do to determine what is that point of mortality at the various salinity levels. So we have requested that through some statements of need through the Corps, and we're also working with our partners at Florida Fish and Wildlife to get some of that research addressed. There had been a previous study on Salvinia molesta being trapped on boat trailers, and they had shown that the plants were able to survive after being crushed between the boat and the trailer for 4 to 8 days when it was out of the water. Plastic materials tended to keep the plants going a little longer than other materials like wood. So knowing that it can survive 4 to 8 days after you pull your trailer out of the water, that definitely helped lend some credence to the possibility that it was brought over from Louisiana or Texas as part of the potential spread pathway. So our next steps with our early detection rapid response, we're going to continue monitoring the drainage downstream from the original pond. We're going to keep filling in the map with our presence and absence data. To date, we have surveyed over 720 individual ponds. Only 3 of those points were positive for Salvinia molesta, and those were the original pond, the concrete line ditch, and the River Oaks Park location. We had 38 locations that had Salvinia minima, but as I said, we've been continuing to monitor those to make sure that they're not, you know, rapidly expanding. So far so good, knock on wood, we have not seen any of that happening. We're going to continue to do thorough monitoring of the St. Johns River and its tributaries. And as I'm doing today, we're going to keep up our outreach and education on giant Salvinia and early detection and rapid response. So with that, I know I blew through that pretty quickly, but I can take any questions as part of the Q&A. Or you can feel free to contact me if you have anything, you know, specifically to discuss.
Great. Thank you so much, Jessica. We really appreciate your time and expertise. That was an awesome presentation. I'm not seeing any questions in our Q&A box. You all were just too thorough. We don't have any questions from our audience. So we're just going to go right ahead to our call to action for the day. We like to close out these sessions with a call to action. We're asking you to write to your legislators to reintroduce the Stamp Out Invasive Species Act. That would issue a semi-postal stamp whose revenue would go towards invasive species management programs in the Department of Interior and Department of Agriculture. So you can go ahead and scan that QR code or click the link in the chat and send off your letter. And I think if we want to go to the schedule slide next. All right, so we're coming up on our last day of NISAW tomorrow. We do have 3 webinars lined up, so be sure to go to nisaw.org and register for those. We hope to see you there, and thank you all so much for attending, and thanks again to our speakers.